Okay, here we go.
Okay.
Here we go, you hard workers. So like I said, these are going to be your fraction notes condensed all the way down. That way, when we're doing stuff in algebra, when we get into the book and you want to know something about fractions, then you would just look here. It would be the same idea. So the first thing that's in your notes book right now, this should be the very first thing that's in your notes book. Because anytime you have questions about integers, we're past integers, this should be the very first thing. The second thing in your notes, in the front of your notebook, is now going to be fraction rules. Okay? Here we go. So now you're going to have fraction rules behind your integer rules. So every time for the whole year you're working, you have a condensed place to do that. It says write 7/8 as a decimal. What's another way to say 7/8? 7 divided by 8. 7 divided by 8. 7 divided by 8. Then we put our decimal in, we bring it up. 8 cannot go into 7, so I put a 0 above the 7 to hold that place value. There are no whole numbers for 64. 8 times 8 is 64. 70 minus 64 is 6, so I'm putting it under this number. Some of you are doing okay, but you're not lining up stuff. So you kind of get lost sometimes in what's going on. This is another point I want to make. After I subtract, the number that I get must be smaller than the divisor. If this was 10, that means I didn't go in enough and I'd have to up this number up here. So every time you're done subtracting, you draw your line, you subtract, make sure your number is smaller than the divisor. All right, it's smaller, so now I add another 0, bring it down. 8 into 60, 7 times 8 is 56. 60 minus 56 is 4, and I check. Yep, 4 is smaller than the divisor, so I'm good. Another 0. Exactly. 8 into 40 is 5, and it works out evenly. So my answer then is 0.875. It says to write 7 2/5 as a decimal. I did this a lot on the test that we took. This is the part you're trying to change. If you change it to an improper fraction, you have bigger numbers that you have to divide. We already know that we have 7 whole ones. 7 point. We're just looking for the decimal part. So instead of doing 37 divided by 5, some people are changing it to an improper fraction and then dividing. You can still get the right answer, but the numbers are bigger. So let's just change the fraction part into the decimal. 2 divided by 5. 2 divided by 5. Bring my decimal up in my answer. And I see that 5 cannot go into 2. And when I add a 0, I see that 5 can go into 20 exactly. And so there's the decimal part I'm looking for. So this would be 7.4. 4/9 as a decimal. Some of you are going right to the answer on this. I'm going to do it the long way, and then I'm going to put a star next to this and be reminded of why this is a nice, easy one to do. It would still be the same, 4 divided by 9. Bring your decimal up. 9 cannot go into 4. When I add a 0, 9 into 40. 4 times 9 is 36. 40 minus 36 is 4. When I bring down a 0 again, I see that I'm getting the same thing. 4 again for 36. So we're going to put a star here.
Because you don't have to do it out because it's 4/9, so it would just be 0/4.
Yes, but remember, these are your notes for the rest of the school year. So sometimes as months go on, sometimes you forget. Like I said, these are condensed notes for the rest of the school year. We're going to put a star and put repeating decimal. That means that 1/9 equals what? 0.1 repeating, 2/9, then would be 0.2 repeating, 9ths, 3/9. We don't have to put them all down, but we kind of want to give ourselves an idea that, hey, you know what? 9ths, repeating decimal. Ninths, that's why I put 9ths next to that. 9ths are repeating. Even 99. We saw that when we had 0.45 repeating, it was 45/99. Yeah. If it was 2 of them repeating, so 0.45 would be 45/99. If it was 457 repeating 457, 457, it would be 457 over 999. Yeah, but I mostly just stick with the ninths. I showed you the long way to do it because I wanted you to see that there was a very tedious process to it. So repeating decimal ninths, we have an example there of what it means to be repeating. And so my answer then is 0.4 repeating. And you can go right to the answer. If you've got that memorized and you know how to use it, you don't have to do the long division. But you can see that all of them do have long division. Even the next ones under C would have long division. But I'm hoping that instead of having to do long division every time, there are certain ones that you just know, like the first one. How could I say this to remind myself of what that decimal is? What? Quarters. 1 quarter. How much is 1 quarter?
25.
How about half a dollar?
50. And the last one's 75.
Yeah. It says write a fraction as an improper fraction. And so right here, this is really what we always want to look at. It says that you're going to multiply and then you're going to add 35 plus 3 is 38 sevenths. 38 sevenths. So you are multiplying and then you are adding. And then obviously I wanted to go backwards on this on how do we change the improper fraction back to a mixed number. And so it still says 38 divided by 7. 38 divided by 7. 38 is being divided by 7. Can 7 go into 3? No. I put a 0 above it so I know where to put my next number. I'm holding place value. How many times can 7 go into 38? 7 goes into 38 how many times? 5. 5 times 7 is 35. And when I subtract, 38 minus 35. Now I can write my final answer. I'm not looking for a decimal. I'm looking for a mixed number. How many whole times did 7 go into 38? It went in 5 times. And then I have to figure out how to write the fraction. What is it? You're going to use your remainder and put it over the 7. So it's 3 sevenths. You take your remainder and put it over the divisor. 3 sevenths. So it's remainder over divisor. Okay, now we go the other way. Write decimals as fractions. Of course, we've just been working on this for how long? Fractions into decimals. I'm going to turn my paper sideways so I can write on it better. What's the very first place in the decimal section? It's the tenths. There is no ones place on this side. So tenths, got to kind of write small. Hundredths with a THS. Thousandths. Tenths, hundredths, thousandths, 10 thousandths, and so on. So that's where all our fractions and decimals are fine. Numbers that are less than 1. And when you start to have whole numbers, this is where it starts. It starts in the ones place. These are the whole numbers. Ones, tens, hundreds. So our decimal numbers are all found here, wherever it is. That's where our decimal numbers are found. How do I say this decimal correctly?
0 and 1400.
So you don't have to say the 0 part.
So 1400.
14 hundredths, because it has 2 places. The 4 lands in the hundredths place. So 14 hundredths, you just write 14 hundredths.
We don't have to simplify.
What 3 numbers should I always check for simplifying? What 3 numbers will help me get the majority of my fractions simplified? If I check 2s, 3s, and 5s. So I didn't say 4s because 4 is an even number, which means it's covered by 2. Right? 2 is half the numbers in the number system. So right there, you've already got half the numbers you're able to check. 3 takes into consideration the odd numbers. And then 5 takes into consideration anything that ends on a 5 and a 0. So always check 2, 3, 5. I haven't done that. All right, so I know they're both even, which means I can divide by 2. So I'm going to cut them in half. Dividing by 2 means cutting things in half. 7/50. 7 is prime. It's not even. It has nothing in common with an even number. Okay, now problem B. How do I say this number correctly? Problem B, Caitlin. 5 and 7. It lands in the hundredths place. Tens, hundredths. So 5 and 7 hundredths. So 5 and 7 hundredths. That's it. Again, I have an odd number and an even number. 7 is prime. It has nothing in common with an even number. That's it. Write 0.8 repeating as a fraction. What do we get?
8/9.
It's repeating.
8/9.
I gave half credit on the test if you put 8/10. You just didn't see the repeating part in that. So I put a star next to this. You can make a star like this, just with lines, right? It doesn't have to be colored in. So put a star next to that because that's one of the ones that we have memorized, 8/9. It's a repeating decimal. Okay, here we go. Moving on to multiplying fractions. You guys are doing great at this. So it says rewrite the negative sign in the numerator. You got to kind of write small on this. You got to write small. I tried to not have so many pages here. Now it says simplify. You're going to divide by the GCF, the greatest common factor. Do 8 and 7 have anything in common? No. How about 5 and 15? What is the greatest common factor for 5 and 15? 5. 5 divided by 5 is 1. Get used to crossing it out right there. Don't rewrite stuff. Just cross it out right there. 5 divided by 5 is 1. 15 divided by 5 is 3. And then you just multiply straight across. -8 times 1. 3 times 7. Donald Duck?
No, just maybe like my fractions.
So they have nothing in common. Final answer. 2, 3, or 5 do not work for both of them. Okay, here we go. The first thing it says to do on mixed numbers when we're multiplying mixed numbers is to change the mixed number to an improper fraction. Easy. 2 times 7 is 14, plus 1 is 15 halves, times 3 times 2 is 6, plus 2 is 8/3. Do I have any simplifying with the GCF? Caitlin, you have both of them. So tell me what to do for 2 and 8. Divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. How about you, Evan? Is there any cross-canceling to be done here?
Yeah.
What's the common factor I'm going to divide out? 3. 3 divided by 3 is 1. 15 divided by 3 is 5. And now I just multiply straight across. 5 times 4 is 20. Do I leave it as 20 over 1? No. Exactly. 20 divided by 1 is just 20. Okay, dividing fractions. There's only one thing I have to do, and then I'm right back to multiplying again. Dividing fractions. So when I flip my 5/8, it becomes a multiplying problem. Okay, that's right. You got some cross-canceling to do. Much easier on you if you do it here. The numbers are smaller. 4 divided by 4 is 1. 8 divided by 4 is 2. 3 times 2, I multiply straight across. 3 times 2 is 6. 1 times 5 is 5. Is it okay to leave my answer as an improper fraction?
Yeah.
Yes. Is it reduced?
Yes.
Yes. We have mixed numbers, and the first thing is the same thing when you're multiplying fractions. Change it to an improper fraction. Do not use the negative. It's just 5 times 6. 5 times 6 is, Jaden, please. 5 times 6 is 30, plus 2 is 32/5. And now I'm going to put the negative with the numerator. We're still dividing. All we're doing is changing to improper fractions. 5 times 2 is 10, plus 1, 11/5. And now I'm going to use the reciprocal, and I flip it, and it becomes 5/11, and that changes it back to a multiplying problem. Is there any cross canceling that can be done?
Yeah.
Just the 5s. 5 divided by 5 is 1. 5 divided by 5 is 1. And then I just multiply straight across. 11 has nothing in common with 32. 22, 33, 44, but not 32. So just multiply straight across. Negative 32 times 1 is negative 32. 1 times 11 is 11. Okay, we have common denominators here. So again, these are your notes. All we're doing is 5 plus 9 divided by 12. Take the numerators and put them over your common denominator. And then simplify. Again, not everybody is doing all these steps, but it's good to have the notes. Good to see what it is that you're doing in your notes. You know, I'm trying to help you to be good at using your notes and being independent. And then I need to simplify. What 3 numbers should I always check?
It's divided by
2, 3, 5. Do any of those work?
2.
2. They're both even.
7/6.
Cut them in half. We have a common denominator for letter B. So I'm just going to write what it says. What does it actually say for the numerator? I know it's 8 in the denominator. But what does the numerator going to say?
3 plus 7.
No.
3 minus negative 7. 3 plus negative 7? I don't know.
Say it. Evan, what do you think it says? It says 3 plus negative 7. 3 plus negative 7. Now we kind of see our integer rules here in the numerator. I know it's going to be over 8. 3 plus negative 7. Are we adding like signs or unlike signs?
Unlike.
They're unlike.
So you minus.
So you subtract them. 7 minus 3 is 4. Is it going to be a positive 4 or a negative 4?
Negative.
The 7 is bigger, and so I take the sign from the 7, and then I need to simplify. What kind of fraction do we get when we see the numerator is exactly half the denominator?
That's a half.
It's the fraction of half. I divide both by 4, and I'm going to get a negative half. But if you recognize 4/8, it's the numerator is half the denominator every time. If you have 16 over 32 or 25 over 50, you can be like, hey, that's a half. Okay, so that's adding fractions.
Regrouping.
We went to regrouping and borrowing this week. And so we were trying to borrow from the whole number. So the 5 becomes a 4. I'm borrowing 1. And I put that 1 right in front of my fraction. So now I have a mixed number that says 1 and 5/12. So I change it to an improper fraction. I get 12 times 1 is 12 plus 5 is going to be 17/12. So my final answer here, what's my final answer? It's 4 whole ones.
4 and 17.
And then I have 17/12. And then I can subtract fractions when I have something like that. So that was just about borrowing. How do we borrow? Borrow from the whole number, put it with the fraction, change it to an improper fraction. Let's see that in action. So 2 and 5/8, we write it vertical because it's just so much easier to find common denominators. When we write it vertically, we can just do the work right next to it. It lines up better. What's the rule for adding and subtracting fractions? Exactly. Need a common denominator. That's important. Need a common denominator. Okay, common denominator. What is the common denominator for 8 and 6? Aiden, what do you think? What would be a number that both 8 and 6 could go into? 32 works for 8.
48.
48 works, but that's too high. I want to go with the least common denominator. 24.
Oh.
24 works for both of them. So I'm going to come over here and put 24, make a space there because I know there's some writing that I want to do. Again, if I used 48, fine. It just means I'd have to reduce more at the end. All right, now we got to adjust our numerators. 8 times what was 24?
3.
3, so I got to do the same thing to the numerator. 5 times 3 is 15. And then 6 times what is 24? 6 times 4 So 5 times 4 is 20. I'm going to stop there for a second, make sure everybody's caught up. So what's the problem here? Can I do 15 subtract 20? No. I need to borrow. I cannot do 15 subtract 20. So I borrow from the 2. That becomes a 1. And then I put the 1 in front of the fraction I'm working with. I create a mixed number. 24 times 1 is 24 plus 15. That's going to be 39. 39 24ths. Now I can do 39 24ths subtracting 20 24ths. Very good. 39 minus 20 is 19 over my common denominator. Do I have any whole numbers? No. 1 minus 1. Remember, using this number over here. Not this one. Using this one. 1 minus 1 is 0. So we just have 19 24ths. We have adding, and again, I like to line these up vertically. 2 and 1/5 plus 1 and 3/4. It just makes it easier to find the common denominators next to them. What's the common denominator for 5 and 4? 20. Okay, go ahead and adjust your fractions. Let's see how you're doing. 5 times 4 is 20, so 1 times 4 is 4. 4 times 5 is 20, so 3 times 5 is 15. Do I have to borrow? It says 4 and 15. So you're adding. So no, you don't have to borrow, only when you're subtracting. And over here, on this one, I'm going to put a little star that says borrow. Borrowing, so that when you're looking back and you're looking for an example about borrowing, you'll see that right there. You don't have to borrow when you're adding, you just add them up. So we have 4 plus 15 is, again, 19 20ths. And then you add your whole numbers. 2 plus 1 is 3. Final answer.